So hi everyone, my name is Samreen Anjum and I'm a third year PhD student at University of Texas at Austin. Like Vaisham just mentioned, my research focuses in computer vision and in human AI partnerships. And I'm specifically interested in working on the problem domain of multiple object tracking in videos. And I'm joined here today with my lab mate, Yinan Zhao. So we'd like to thank you for spending your weekend with us and learning more about our team's work on describing images taken by the blind, by people who are blind. I just want to mention that the credit of most of this work, as well as for these slides, go to our advisor, Dr. Danna Gurari, who's also a professor at University of Texas at Austin. So with that, let's begin. So here's a quick agenda for what we're going to discuss today. This is a big topic, so I'm going to start off with first introducing the data set, the motivation, and what makes this data set challenging for current AI algorithms. And then we're then going to introduce 4 AI challenges which emerged from this data set. And then finally talk about how you can participate in the upcoming challenges that we have for this year. So we're going to divide it into 2 halves. So I'm going to cover the first half of this talk, and then Yinan will cover the rest of this section. So first, beginning with the task at hand. So given images such as these, there are several tasks that we can use to help describe such images. For example, in this case, we have this image taken by some individual, and we can have a caption which describes this image as a bunch of small light brown mushrooms in a green field. Another task that is related to describing such an image is called a visual question answer. In this case, with an image, we have an associated question. In this case, we have questions such as, is this edible or poisonous? And we hope to receive an answer saying that in this case, this is a poisonous mushroom. So for many of us, this must be an easy or a simple task, but for people who are blind, this is a challenging task, and there's approximately an estimated of 39 million people worldwide who are blind. So to help people with these kind of problems, nearly 10 years ago, there was a mobile app that was built called VizWiz. And the goal of this task was to help people who are blind get descriptions on their images. So what it did was a person could record an image with the phone by double-clicking on the application. The person could then record an optional question associated with that image, and then have both of these information sent to a team of crowd workers who would then respond in terms of a caption or an answer. So while this was built in, I think, 2010, several similar applications followed and have been helping people who are visually challenged to answer questions related to their surrounding images. The issue with these kind of apps, though, is that they rely on humans, and we know with that comes cost. They're often slow, and there's also privacy issues when people share their confidential information. So our aim of our group's aim was to teach computers to automatically describe such images from real users. In our case, those are people who are blind. And so typically what happens here is in a typical computer vision pipeline, we have a data set created. So we have a bunch of images which describe a certain data set. We feed that data set to an algorithm to train the algorithm, evaluate the performance of that algorithm. And then eventually that algorithm is deployed for real users. But in several cases, we noticed 3 key challenges which occur from questions that are taken from real users. That is, one is most of these data sets which are artificially created do not really match real users' needs. The second we noticed was the current algorithms do not really perform well on the images that are collected from real users. And the third is that real users' data actually reveals several new problems which were not noticed in prior visual question answering data sets. So going deeper into this, so the first problem is the data set mismatch. And for that, what our team did was analyze the previous data set. So here's an example of what prior data set existed. And this is prior data set of visual question answering. So you'll notice most of these, so the top row is from prior work. These are 3 examples from prior work. And the bottom row is examples from our data set VizWiz, which is collected from real users. The key difference in the first previous work is that both picture and question are often collected independently. And what I mean by that is pictures are collected from internet, often from Flickr and databases such as those. And then people are asked, some other people are asked to form questions from these based on these images. So for example, in this one, you'd see that based on this image, the question is the bus moving? What room is pictured with the sink? And what food is on the plate? Whereas with real users, we noticed that the same question, the same person takes the picture as well as asks the question. And the data often reflects users' real interests. So in this case, it could be questions such as, can you tell me what flavor this is, this yogurt is, and then what temperature is my thermostat set to, or whether my sneakers match my clothes or not. So these are like everyday questions versus these are more of like the images are clearly taken, whereas these images are not, these are more haphazardly taken. So the solution for that was to build a data set from the existing data set, which was collected by VizWiz. So over 11,000 people submitted 72,000 requests to the VizWiz application back in 2011 to 2015. And what we did then was used 44,700 images. So that's roughly 62% of the requests, which users agreed to share. And then we performed several steps to ensure that the privacy content was taken care of. And to do that, the first thing we did was we transcribed questions in such a way that it removes voice. We resaved the images by removing the metadata, and that includes location, time, etc. The next step we did was we went through all of the data and identified those images which contain personal information and removed those. So that includes faces, medical information, or addresses, or private information. Once we filtered that data set, we then sent it out to the Amazon, to crowd workers at AMT, Amazon Mechanical Turk, to collect high quality answers for the questions or captions related to the images. So all in all, at the end, we had over 32,000 image question pairs for the VQA data set. And for each of those questions, we have 10 answers. So that's why we have a total of over 328,000 answers. For the image captioning data set, we have 39,000 images and around 195,000 captions. And that is for each image we collected 5 captions. So with that, this data set was the first data set where real users could request image captions and answers to their visual questions to support their real daily life needs. So a couple of things that was different from the prior data sets was that in this data set, because it originated from real users, most objects were commonly found. So that's, most people asked about common objects. So that's table, bottle, package, person, computer, hand, etc. The other thing was that most of the questions, the majority of the questions was where people wanted to know what is in that image. So that is, what is this? There were also questions which asked, what is in this can? What color is this? And what does this say? The other thing which was again different from prior data sets was most questions began with a rare word. In this case, it was please, hi, okay, as opposed to questions such as what, why, and things like that. We have this visualization for you where you can go to our website, VizWiz.org, and then have a look at our existing data set. So you can scroll through a bunch of images on how they look like, and then click on any of those images and look at the information that we collected from crowd workers. So in this case, it includes some of the question associated with the image as well as the answers collected. So that's 10 answers per question. And then the 5 captions that describe this image. So now that we have a data set, the next question was, how do current algorithms perform on this data set? So for that, we performed, for both the visual question answering as well as image captioning problem, we performed benchmarking with existing algorithms. And we noticed that in general, algorithms perform poorly. So in this case, for VQA, where we expected a best answer to be closer to 1, we noticed that the best it can do is closer to 0.448. And the same we noticed in the image captioning as well. And the point here is just that in terms of both VQA and as well as captioning, this data set poses challenge to existing algorithms. So what we did was then try to understand why this data set is challenging for existing algorithms, and figured out a few reasons behind this. So first was because this is real images collected from people who are blind, most of the images are low quality. So around 52% of the data set contain low quality images. The second reason was most of that's about 63% of it contained text. So that required analyzing or understanding text in images. And this actually spurred another challenge, which is called Text VQA. And if you're interested, you can have a look at that as well from another team. And then another thing was it contained novel concepts. So in this case, it contained new objects such as facts, thermostats, CAPTCHA, currency, barcode, and things like that. So these are more of like real things that you come across in your daily life. The other thing we did was we tried identifying what category each of these questions belong to. So for example, several of these questions required understanding objects, so object detection. Some of them required understanding color, so color recognition. Some required textual recognition, so it had to be that the algorithm should understand what text it is and answer that. So in this case, it was when does this expire? And then another few questions were also related to counting. So in this case, the question was, how many pair of shoes are on the floor? So here are a couple of more examples from the data set. So this is about 46% of the questions that involved reading text. So in this case, you can see the first question was, could you please tell me what is in the scan? So that required reading from the image. Another one asked, what are the directions for someone who is 10 years old? And they give a snapshot of, I think it's a prescription bottle. And then looking at the TV on their monitor, they asked, do I have to hit anything or if a particular key combination to make it work? So these are questions that involved reading text. Here's some other examples that involved recognizing color, and that was about 28% of the questions. In this case, someone needed to know if their shirt was clean or dirty, what is the color of their shirt, and whether their pant and shirt matched or not. So to solve this, we tried to broadcast this data set further to larger community and engage a larger community here. And we have all of our data sets available online on this data set. And under each of these tasks, which are interested, you can go and check them out and download the data sets. What we did then was we built challenges around these data sets. So you can also click on those challenges and see how you perform against the international community. This data set is also being shared by others. So you can also find them on academic torrents, on Kaggle, as well as on Facebook. And then you'll notice this data set has got attraction around the world with people writing blogs about it and people participating in our challenge and posting about that. So if you're interested, we'd like to invite you to join this task. And this is a quick preview of how it works. And Yinan will later discuss a little more detail on how you can participate. So what we do is we have our data set, which we have split into training and test data set. And both of these sets contain images, associated questions that were asked by those real users, and then the answers that we collected from the crowdsourcers. You will be given the training data set, so you can download that freely on our website. However, for the test data set, we have hidden the answers from you so that you can participate in the challenge. And what you need to do is you need to design an algorithm that can predict on the test data set and submit that to Eval AI, which is a platform that we use for our evaluation server. So while that was there, we noticed that another thing that it came across was while this data set was created for visual question answering or image captioning, real users' data revealed some new problems, and which was exciting for us. And Yinan will now go over those new challenges and how you can participate in our challenge as well. So I'm going to stop sharing. Does that work?
Yeah.
Mm-hmm.
Let me take over. Can you see the screen?
Yep.
All right.
Yes.
Yeah. Okay. Cool. So I'll just continue. Thanks, Samreen. So hello everyone. I'm Yinan Zhao. I'll continue to introduce our quality and privacy challenges together with our CVPR workshop. So real users data collected in VizWiz reviews new challenges. The first challenge is low image quality. In image captioning, 9% of all the images have quality issues that are too severe to recognize the content. As shown in this image, common quality issues include too bright, too dark, image blur, finger occlusion, bad framing, and so on. If we include these images in training, the training set is noisy, which might harm the trained captioning model. If we can classify unrecognizable images, we can exclude those noisy images and obtain a cleaner data set. Similarly, in VQA, 29% of all the visual questions are not answerable, either because the image with low quality is unrecognizable or because the image is of good quality, but the answer to the question is missing in a recognizable image. So if we can estimate image quality, we can provide more fine-grained guidance to photographers regarding how to modify an unanswerable visual question to be answerable. Motivated by the aim to tie the assessment of image quality to practical vision tasks, we introduce a new image quality assessment dataset that emerges from a real use case. Our dataset is built around the VizWiz dataset. For each image in VizWiz, we ask cloud workers to either supply a caption describing it or clarify that the quality issues are too severe for them to be able to create a caption. We call this task the unrecognizable classification task. For example, on the left, I show an image in our dataset with no flaws. On the right, I show an unrecognizable image. We also ask cloud workers to label each image with perceived quality flaws. Blur, overexposure, which means too bright, underexposure, which means too dark, improper framing, obstruction, and rotated views. In the middle, I show examples of these 6 quality flaws. We call this task the quality flaws classification task. Altogether, we call this dataset VizWiz quality issues. Algorithms developed for these tasks can be of immediate use to blind photographers. Here is the annotation format. The annotation is in JSON. The number for each flaw is the number of votes out of 5 crowd workers for each quality flaw and unrecognizability for each image. Another challenge in our collected real users data is private content. 12% of images show private content. Of these private disclosures, some were intentional. For example, people may take a picture of prescription pills and ask others to read the instruction for them. Quantitatively, in VQA, 1 out of every 40 visual questions intentionally ask about private content, meaning blind people are compromising their privacy in exchange for visual assistance. We find that people commonly ask about pregnancy tests, pill bottles, letters, and street signs. However, in some other cases, the privacy leak is unintentional. We want to distinguish intentional and unintentional privacy disclosures so that we can warn users about unintentional privacy disclosures while not influencing intentional disclosures. To address the privacy challenge, we introduced the first visual privacy dataset originating from people who are blind in order to better understand their privacy disclosures and to encourage the development of algorithms that can assist in preventing their unintentional disclosures. For each image, we manually annotate private regions according to a taxonomy that represents the privacy concerns relevant to their images. Basically, the annotated categories can be divided into 2 buckets: private text category and private object category. We also annotate whether the private visual information is needed to answer questions asked about the private images. These annotations serve as a critical foundation for designing algorithms that can decide whether private information is in an image and whether a question about an image asks about the private content in the image. Here is the annotation format. The annotation is also in JSON. For each private region, we annotate its class and the polygon region to represent it. We also provide a flag QA private, which indicates whether a question about an image asks about the private content in the image. We have two tasks in this challenge. Task 1 is private visual information recognition. Given an image, the task is to predict if private content is present in the image. The confidence score provided by a prediction model is for private and should be in the range of 0 and 1. We use average precision as the evaluation metric. Task 2 is intentional privacy leak recognition. Given an image and a question about it, this task is to predict if the question asks about the private visual information. In order to distinguish between intentional and unintentional privacy disclosures, the confidence score provided by a prediction model is for QA private and should be in the range of 0 to 1. We also use average precision as the evaluation metric. Our annotation for private regions can also be used for training detection algorithms for private content. We don't include detection in our proposed challenge, but it's possible to utilize the annotations for other tasks. In this year's CVPR, we will host our VizWiz Grand Challenge workshop. Our goal for this workshop is to educate researchers about the technology need of people with visual impairments, and while empowering researchers to improve algorithms to meet their needs. A key component of this event is to track the progress on 2 dataset challenges, where the tasks are answer visual questions and caption images taken by people who are blind. Winners of these challenges will receive rewards sponsored by Microsoft. The first place winner will win 10K Microsoft Azure credit. Second place will win 5K. The second key component of this event will be a discussion about current research and application issues, including by invited speakers from both academia and industry who will share about their experiences in building today's state-of-the-art assistive technologies, as well as designing next generation tools. Here is the list of our invited speakers. This workshop is co-organized by UT Austin, UW, CMU, Apple, and Microsoft. Here are the co-organizers. It's sponsored by Microsoft. All right, so next I will briefly walk you through how to submit for this challenge. And so basically we host our evaluation server on a platform called Eval AI, and in the bottom is the link for this challenge for the caption challenge. Like we have 2 challenges, caption and VQA. So this is the link and basically the interface overview for the caption challenge, and this one is for the VQA challenge. It's also hosted on Eval AI server, and the interface is quite straightforward, I think. Basically, if you go to the challenge, the caption challenge website, if you click the submit button, there will be submission guidelines, and you can submit your result file for the test set. And we have evaluation script on the back end, and then after run maybe for a minute, it will give you the scores for the evaluation metrics. And if you click the leaderboard, you can see the scores for your team and also other teams, so you can know your rank in this challenge. Yeah, so we share, and you can find all the information in our website. So basically, the URL is vizwiz.org, and yeah, we have 5 challenges, 5 tasks for our VizWiz dataset for our challenge, including image captioning, quality issues, VQA, reasons for answer differences, and visual privacy. we want to, in the end, we want to acknowledge our contributors, dataset challenge support, and more than 3,000 cloud workers for their hours. Without them, our dataset is not possible. Yeah, and I'm happy to take any questions.